Good afternoon, dear students. Today we'll start with module 3, that is pavement materials. So in this pavement materials, which are the materials are used in the pavement construction and their limits as per the different boards and how they are going to utilize that one in the construction process of this pavement. So that one we are going to study in this module 3. So usually in the structure of the highway, that embankment and subgrade are to be constructed with soil, right? So that is one the construction material in the pavement, and this soil is considered as one of the most principal highway materials. So these soils are mainly of mineral matter which is formed by the disintegration of the rocks by the action of water, frost, temperature as well as the pressure. So usually in this module, these are the contents. First one, the subgrade soil, that is the bottommost soil of the pavement, and after that the desirable property of the soil. So how actually that soil should be, and based on the HRB, the soil classification. HRB means Highway Research Board, and determination of CBR, that is California bearing ratio. Usually this CBR value will be helpful in the designing of the pavement. And next, the determination of modulus of subgrade reaction of soil and problems on this, and the further materials like the aggregates, different types of the aggregates, and the desirable properties of these aggregates and tests on these aggregates. And the next material, that is bituminous materials, that is explanation on tar, explanation and bitumen, cutback and emulsion will be there, and then this test on bituminous material. So that thing we are going to study in this module. So subgrade soil. So here you can see in the diagram, so it is with the different layers which are given with the different colors. So first one is this subgrade. So usually this subgrade, which is the bottommost layer of the pavement, so which is going to carry the entire load, which is governed by the subbase, base course, and then this surface course. So in this diagram you'll be seeing the so many layers that is made up of. By using these layers, it is made with the entire pavement. So that bottommost layer will be the subgrade, and then the subbase course will be there, and then base course, and on top that is surface course. So here you can see the 4 different layers, so each will be having the different properties, and here that entire load governed by this roadway. So what you can see the roadway here. So this entire load which is transferred, roadway load which is transferred first to the surface course, and through the surface course it is coming to the base course, and then to the subbase course, and at last it reaches to the subgrade. So subgrade is nothing but that bottommost layer of this pavement. So subgrade, which can be defined as the compacted layer, generally which is of a naturally occurring local soil and which is just beneath the pavement crust, which providing a suitable foundation for the pavement. The subgrade in the embankment, which is compacted in 2 layers, usually to a higher standard than the lower part of the embankment. The subgrade, whether in a cutting or which is in an embankment, it should be well compacted to utilize its full strength and to economize on the overall pavement thickness. So subgrade soil is a gathering of a deposited earth material or derived naturally from the breakdown of rocks or delay of undergrowth than the excavated readily with the power equipment in the field of disintegrated by gentle reflex mean in the laboratory. The supporting soil below the pavement and its special under is called the subgrade. So without any interruption, the soil beneath the pavement is called the natural subgrade. So compacted subgrade is the soil compacted by the inhibited movement of heavy compactors. Followings are the desirable properties of the subgrade soil. That one we will study. So subgrade soil, which is an integral part of the road pavement structure, which is directly receives the traffic load from the pavement layers. The subgrade soil and its properties are important in the design of the pavement structure. The main functions of this subgrade, which is to give the adequate support to the pavement, and for this subgrade it should possesses the sufficient stability under adverse climate and loading conditions. Usually you have seen the formation of waves, corrugations, rutting and showing in blacktop pavements, and the phenomenon of pumping and blowing, and even you can see the consequent crackings of cement concrete pavements, which are generally attributed due to the poor subgrade conditions. So the phenomena such as like the formation of the waves, the corrugations and the rutting and all what you can see on the pavements, so that is because of the poor subgrade conditions. So coming to the next part, that is desirable properties of soil. So desirable properties means so how actually that soil it should be in the construction part. So in this, these are the following properties. First one is stability, incompressibility, permanency of strength, and minimum changes in the volume and stability under adverse conditions of weather and groundwater, good drainage, ease of compaction. So in that, first one is the stability. So stability in the sense that soil it should be stable so that it should withstand all the loads governed by the top layers such as base course, sub base course and surface course, and through that surface course that entire load of the vehicles will get transferred. So it should able to withstand these all loads governed by the top layers as well as that vehicle loads. And then the incompressibility of soil. So usually the compressibility of soil means what? So when the moisture content of the earth reacts with the soil, so there will be a change in its volume. So here the soil which is used in the construction of the pavement, it should be incompressibility. So incompressibility means what? Usually the gravels, sands and silts are incompressible materials in the soils. That is, if a moist of a mass of these materials which is subjected to the compression and they suffer no significant volume change, that is when these soil such as gravels, sands and silts reacts with the moisture content of the earth, there will not be a much changes in its original volume. But the other classification of the soil such as clays and other things, so when it reacts with the moisture content of the earth, there will be a change in its volume. For example, you can take the black cotton soil. So usually in the summer season and all it will get expands, and in the winter season and rainy seasons due to the rainwater it will get shrinks, and then there will be a change in its volume. So similarly the soil particles which are used in the construction of the pavement, it should be incompressibility such that when it reacts with the moisture content there will not be a much change in the volume. And next one is the permanence of the strength. So permanence word which refers to the reflection, the permanence word which refers to the retention of properties such as strength and color over the extended period. So often after certain periods, that whatever the strength and whatever the color and whatever the properties of the subgrade are there, it should be similar as constructed in the previous time. And I mean at the initial stage how that property has been maintained, so after certain years that property it should be remains same. So here we should maintain the strength in a permanence way, so that is influenced by both internal factors as well as the external factors. So next one is minimum changes in the volume and stability under adverse conditions of weather and groundwater. So here might be the soil property may get changes because of changes in the volume and stability under adverse conditions of weather and groundwater. So if you take one example, that is the groundwater. So because of the groundwater, might be it may get reacts with the subgrade soil and then it may loses its entire property. So here whatever the soil is used in the subgrade, it should be sufficient to withstand that, not reacting with the groundwater, as well as because of the climate changes, because of changes in the climate, it should not changes with respect to the volume. So good drainage system. So here soil, whatever the rainwater or water particles which is reacted with this soil, it should not withstand with the maximum time. So it should have better drainage, it should be proper the percolating property in its structure such that the water can easily percolate through that soil. So next one is the ease of compaction. So here the soil compaction which occurs with the when soil particles are pressed together, and the main intention of this compaction is to reduce the pore space system between the particles, and heavily compacted soils which contains few large pores and less total pore volume and consequently a greater density. And a compacted soil which has a reduced rate of both water infiltration as well as the drainage. So if it is well compacted, so a compacted soil which has a reduced rate of both water infiltration and drainage, this is happens because large pores more effectively move water downward through the soil than the smaller pores. So in addition, the exchange of these materials because of the good compaction, so it provides